Hello, my name is Mr. Asprey and this is AQA Level 2 Certificate in Further Maths, Paper 1 from June 2021. If you do find this video useful, please do like the video, that would be greatly appreciated. And if you're not subscribed already, please do so. I've got lots more content planned for the run up to the exams to hopefully help you ace your exams, which would be fantastic. Okay, so without further ado, let's get into the maths. Question 1, we're asked to find the distance between 2 points. Now we need to use the length equation, which is the square root of the differences in the x squared plus the differences in the y squared. So essentially making use of Pythagoras' theorem. So the difference in the x, well, that changes by 8, so that's 8 squared. And the differences in the y, well, that changes by 6, so 6 squared, square rooted, which is the square root of 64 plus 36, which is the square root of 100, which is equal to 10. Question 2 is asking for the rate of change of y with respect to x, and that is our good old friend dy by dx, aka the derivative. So in order for me to differentiate, I need to write out my y function as just a list of x's. So I'm going to multiply out these brackets to get 2x to the 5 minus x to the 7x to the 4. And now I can differentiate, and when I differentiate, I bring the power down multiplied by the coefficient to get 10, and then I drop the power down by 1, and again multiply the power by the coefficient, and then drop the power down by 1, and I have differentiated that function. Question 3 tells us there are 4 sketches, and we want to circle the letter of the sketch that represents this equation here. So I'm going to rewrite that equation to make y the subject. So I'm going to minus 3x to both sides, and then I'm going to divide through by 2. Now this will tell us what the gradient is and what the intercept is. So I have a gradient of minus 1.5 or minus 3 over 2, so a negative gradient, and I have an intercept which is positive. So I'm looking for the equation or the sketch, and I think it's this one, which has a negative gradient, i.e. going downwards, and has a positive y-intercept. And these two have positive gradients, so yes, it's not those two. Okay, we have a function and we have a particular range. Work out the domain of the function. Well, the range are all the outputs. So when the output is at its lowest, then 3x minus 5 is equal to 13. So therefore 3x is equal to 18, so x is equal to 6. So that gives us our lowest possible value. And what value of x gives us our highest possible value? Well, that's when it equals 19. So 3x is equal to 24, so x is equal to 8. So therefore our domain must be that x is between 6 and 8. And not equal to, because these symbols here are strict inequalities, they are not equal to either. And for this question, it's a good idea just to draw a quick sketch so that you have x between minus 1 and 3, and we're going to have a and at minus 1 we know we have a value of minus 1 squared minus 4, which is minus 3, and at 3 we're going to have a value of 3 squared minus 4, which is 5. So this graph is going to look something like this, minus 3, and it's going to go up here at 5. But we also know when g is 0, it's going to give me a value of minus 4, so it's going to cross this axis here at minus 4. So our graph is going to look something like that. And we can see from there that the lowest possible value is this part here, which is at minus 4. And the highest possible value is this point here, which we said was 5. So it's between minus 4 and 5. But remember that it can actually hit this value, so it's therefore equal to as well minus 4. But it can't equal the 5 one, because when I sub in 3, I get 5, but I can't actually sub in exactly 3 because my x value is less than 3. And here we have a function h, work out the inverse. So to work out the inverse, I write y is equal to this function. I then swap my x's and y's over, and this will give me that x is equal to 3 plus y over 2, and then I make y the subject of that equation. So I'll times by 2, and then I will subtract 3, and this is my inverse function, 2x minus 3. So I write the inverse function is 2x minus 3. Question 5, we've got the nth term of this sequence, and a term of the sequence has a value of 5. Work out the value of n. So I need to set the nth term equal to 5. So I write this over this is equal to 5. I multiply both sides by n plus 1, which will give me 5 lots of n plus 1. I'm going to expand these brackets to get 5n plus 5. Subtract 2n from both sides. Subtract 5 from both sides. And finally divide through by 3, and I get that n is equal to 14. It says write down the limiting value of the sequence as n tends to infinity. Well, what you can do is you can imagine what would happen when n is a large number. So you're going to get 2 lots of infinity plus 47 over 1 lot of infinity plus 1. And of course, if you add 47 or 1 to infinity, then it's just going to be infinity. So it's 2 lots of infinity over infinity, and the infinities will cancel and you're left with 2. So 2 is the limiting sequence of that, limiting value, of that sequence. Here we have a sine graph, and we're given that sine of 220 is equal to minus k. So that means that at 220, which is roughly there, if I draw a line down and then a line across, this value here is minus k. And then it's going to ask me what two values of x for which y is equal to k. So when is y is this, on this graph is sine x, so I want to know when sine x is equal to k. Well, this graph is completely symmetrical, and if I were to draw a line up here at positive k, and then I'll draw a line down here, we can work out what that value is, because from 180 to 220 is a gap of 40, so going backwards 40, that will give me 140. So that's one of the values. And then again, because this graph is completely symmetrical, this gap in here is the same as this gap over here, and that gap is 40. So the gap from 0 to that line is 40. So it's 40 and 140 are our final answers. Question 7 looks like a quadratic inequality. So what I'm going to do is I'm going to expand these brackets here like such, and this is going to give me 2x squared plus 2x minus 3x minus 3. Actually, it's not going to be a quadratic inequality because these will cancel, so I'll just be left with 4 is greater than 2x minus 3x is minus x minus 3. To be very careful not to divide or times by negative, because that will flip the sign. So instead I'm just going to add x to both sides, and then I'm going to subtract 4 from both sides, and I get x is greater than minus 7. Okay, so simplify. I'm going to multiply out these brackets. Actually, I want to keep my numbers lower. So what I'm going to do is I'm going to simplify first inside the bracket. So 75 is the same as 25 times by 3. And 48 is the same as 16 times by 3. Okay, this is going to make it much easier, because now what I've got is 5 root 3 and 4 root 3. So inside the bracket I have 9 root 3. So I need to just do 9 root 3 times 3. So I could write it like this, 9 root 3 times root 3. And root 3 times root 3 is 3, so this becomes 9 times 3, which is 27. Okay, we're going to expand a triple bracket next. So what I will do is I will pretend like the first one isn't there. And I'm just going to expand this double bracket here. And that's going to give me 3x squared is going to give me 6x minus 4x minus 8. And then I will simplify that down by adding the two x terms to make 2x. And then what I'll do is I'll reintroduce my 2x minus 5. Like such. And then what I need to do is I'll need to multiply 2x by minus 5 by everything in this term. So I'm going to times 2x by all of these three. And then I'm going to times minus 5 by all of these three. So doing the 2x's first is going to give me 6x cubed plus 4x squared minus 16x. And then doing the minus 5s, minus 15x squared minus 10x and plus 40. I'm then going to collect up the x squareds, of which I have 2. Well, I've got 6x cubed. For the x squareds I have minus 11. And then I'm going to collect up the x's, and that I have minus 26. And then plus 40 on the end, and we are done. And this is how I solve quadratic sequences. There's lots of ways of doing it, but this is how I do it. And I look at the gap between them, and in this case it's positive 1, then negative 1, then negative 3. I then look at the second differences, and in this case it's going down by 2, so negative 2, and again it's going down, so negative 2. I then take this value and I half it, and I call this my A value. So my A value is the differences, the second differences, and then that's halved. So that's minus 1. Next I write the sequence out again, like this, and I draw a little table, and here I write minus 1 because of this term here, n squared. So when n is 1, I'm going to get minus 1. When n is 2, square it gives me 4, then times by minus 1 is minus 4. When n is 3, square it, 9 times minus 1 is minus 9. And when n is 4, 16 minus 16. And then I subtract that sequence from my sequence that I started with. So 0 minus minus 1 is 1. 1 minus minus 4 is 5. 0 minus minus 9 is 9. And minus 3 minus minus 16 is 13. And I should get a linear sequence here. And I do. And that linear sequence has a gap of 4, so it's 4n. And I would need to subtract 3 from the first term of 4 in order to get 1. So my quadratic sequence is the two of these two things added together. So that's minus 1n plus 4n minus 3. Sorry, minus n squared plus 4n minus 3. Okay, matrix multiplication. So I'll write out my matrices like this, and I'll have A, B, 0, and 0.4. And I'm going to multiply these matrices together. Now where I do it is I draw a little St. George's flag like this, and I look first at the top left element. The top left I achieve by timesing the top row by the left column. And that's going to give me 2 times A, and then 1 times 0, which gives me just 2A. The next one I'm going to do is the top right. So this one over here, the top right is the top row multiplied by the right column. So this is going to give me 2b plus 1 times 0.4, so that's 2b plus 0.4. And I think that is actually all I need, because I'm told that this is equal to ki. Now I is the identity matrix 1, 0, 0, 1. So when I multiply that by k, then that's the same as k, 0, 0, k. So I know now that the top right is going to equal 0. So that's going to tell me what b is. So 2b plus 0.4 is equal to 0. So 2b is equal to minus 0.4. So b is equal to minus 0.2. That's very helpful. And the next, the top left is going to give me that 2a is equal to k. So actually I need to find k, so I'm going to have to do another element of my matrix, and what I'm going to choose is the bottom right, because that has a k in it. So bottom right means I need to times the bottom by the right, and that's going to give me 0b and 3 times 0.4, which is 1.2, and that's going to equal the bottom right, which is going to equal k. So k is equal to 1.2, so therefore a is equal to k over 2, so a is equal to 1.2 over 2, which is 0.6. Question 12, we have a circle, and it passes through the origin, and it has the point A on the x-axis, and we have a tangent. It says work out the equation of the circle. Well, the equation of the circle, we need the centre and we also need the radius. So the radius I'm going to be able to work out by drawing a line here and writing r, and then by Pythagoras' theorem we could draw a little right angle triangle in here, and this is going to go down 2 because it's going to get to the y coordinate of minus 2 from 0, and it's going to go across 4 because it's going to go to the x coordinate 4 from 0. So I can write that r squared is equal to 2 squared plus 4 squared. So r squared is equal to 20. And the equation of a circle is given by x minus a squared plus y minus b squared is equal to r squared, where a comma b is the centre. So I know what the centre is and I know what r squared is, so I can write x minus 4 squared plus y minus minus 2, which is plus 2 squared, is equal to 20. We're now asked to work out the equation of the tangent to the circle. Okay, I'm going to go back up to my diagram, I'm going to get rid of this, and I'm going to draw a line from the radius to the tangent. And we know from circle theorems that radii and tangents meet at 90 degrees. So the first thing I'm going to do is work out the gradient of this radius, and then that will tell me or I can then work out the gradient of the tangent. Okay, so let's just get rid of this working. It's good to have the diagram near us when we do these types of questions. So the gradient of the radius, so I'm going to call that m1, is equal to the change in the y, so it goes from 0 minus minus 2, over the change in the x, which is 8 minus 4. So this is the same as 2 over 4, which is a half. So the gradient of the tangent, which I call m2, because it's perpendicular, is going to equal minus 1 divided by 1 over 2, or the negative reciprocal, which is minus 2. Okay, great. So now I've got the gradient. I'm going to use my equation for a straight line, which is y minus y1 is equal to mx minus x1. So I need a point. I'm going to choose this point because it's got a 0 in it, which makes it easier. So I get y minus the y value of that point, which is 0. M is minus 2, the gradient. And x minus the x coordinate is 8. And multiplying out those brackets, I get minus 2x plus 16. And that is the equation of the tangent. Okay, we've got a sketch of a exponential graph, and we have a point on the graph. And it asks us to work out the value of k. Well, I need to substitute into my equation because I know that this point is on the curve, so therefore it must satisfy the equation y is equal to k to the x. So y is 3 and a 16th. So I'm going to rewrite that as 3 times 16 plus 1, which is 49. So 49 over 16. Make it an improper fraction. And that's equal to k squared, because the x value is 2. So k is therefore equal to the square root of 49 over 16. And if I square root a fraction, I can square root the top, which is 7, and square root the bottom, which is 4. It says B is a point on the curve with x coordinate minus 1. Work out the y coordinate. Well, we now have the curve, the equation. It's y is equal to 7 over 4x. So let's write that down here. Y is equal to 7 over 4 to the power of x. And if x is minus 1, then the y coordinate is equal to 7 over 4 to the minus 1. And if I raise something to the power of minus 1, it flips the fraction over. It becomes the reciprocal, so that's equal to 4 over 7. Okay, a triple simultaneous equation. I need to create I need to eliminate one of the variables, and I'm going to pick 1 and 2, and I'm going to eliminate b, because the third equation doesn't have a b in it, so that's going to be really helpful. So in order to eliminate b, I'm going to multiply this top equation by 2, and that will give me 8a minus 2b plus 6c is equal to 54. And I'm going to write equation 2 exactly the same, and that's going to line up the coefficients of b nice and neatly, so that because they're different signs, I can add the two equations and I'll get cancellation. This is going to give me 11a, and this is going to give me plus 5c, and this is going to give me 59. I can now introduce equation, or first off I'll label this one 3 and I'll label this one 4. So it's a new equation. And now what I can do is I can line up two different equations, and that will be 3 and 4. So 3 I'll write just directly underneath it like this. And what I can then do is just add these two directly. And that's going to cancel out the c's. So I'm going to get 13a is equal to 52. And I know that 52 is divided by 13 4 times. So I get a is 4. I can then pick, let's go for equation number 4 to work out c. So I have 11 times a, which is 4, plus 5c is equal to 59. This gives me 44 plus 5c is equal to 59. So 5c is equal to 15 by subtracting 44. So c is equal to 3. And then finally, I'll just pick an equation that has b in it. I'll go for equation number 2. Just it's got a positive b. So I've got 3a, which is 4, plus 2b minus a c, which we worked out was 3. And that's equal to 5. So that's 12 plus 2b minus 3 equals 5, which is 9 plus 2b is equal to 5. Subtract 9 from both sides, which gives me minus 4. So therefore b is equal to minus 2. You should always get good-ish numbers, like whole numbers or 0.5s. If you're getting recurring decimals or something like that, then you've probably made a mistake and it's a good idea to refresh. Okay, great. We've got an equation here, which I would need to solve, and I will isolate the tan x. So first off, I will divide both sides by 3. And then I will square root, and I'll be very careful. Whenever I square root, I will get plus or minus an answer, and the square root of 1 is 1, and the square root of 3 is the square root of 3. Okay, so I've got two possibilities here. Now, what do I know when I do the inverse of 1 over the square root of 3? Well, let's just quickly draw our equilateral triangle with side lengths of 2 and 2. A line down the middle, which makes this now 1 and 1. A right angle here. 2 squared minus 1 squared square rooted is root 3 is the height. And if I'm looking at tan of this angle up here, which will be 30 because it's half of an equilateral triangle, so I know that tan of 30 is equal to the opposite 1 over the adjacent, which is root 3. So therefore, the inverse tan of 1 over root 3 is going to equal 30. And if I take the negative value, I would end up with negative 30, but that's outside of the range. So therefore, I'm not going to use that one. So the answer is just x is equal to 30. Question 16, we have a function and we have to use factor theorem. So we have to use factor theorem in order to solve this question. And the factor theorem states that if x minus a is a factor, then this works both ways, that f of a is equal to 0. So if this is a factor, then if I write 2x plus 1 equals 0, 2x equals minus 1, x equals minus a half, that should solve this function perfectly with no remainders, and it should equal 0. So what I'm going to do is I'm going to sub in minus a half. This is going to give me 200 times by minus a half cubed plus 100, and this needs to be squared, minus 18 to the minus a half. And I need to show this because it does tell me that I need to use factor theorem. So I'm going to work out all of these. So that's minus a half cubed is minus an eighth. And an eighth of 200 is like dividing it by 2 3 times essentially. So 100, 50, 25. So it'd be minus 25. And this is like dividing by half twice. So that's 50 and then 25, and that'll be positive because the minus will be squared, which will turn it positive. And here we're going to be, there's 2 minuses, and we're going to half to make positive 9, and then minus 9, and we can clearly see now that that's equal to 0. So therefore we know that it is a factor. It then says hence solve. So once you know one factor, it means you can divide algebraically. So I'm going to write my factor there, and I'm going to write my polynomial, which is 200x cubed plus 100x squared minus 18x minus 9. That's correct, right there. Okay, it's all about the lead terms. So 2x, and in this case, 200x cubed. So how many times does 2x go into 200x cubed? Well, it goes in 100x squared times. I then multiply 100x squared by the 2x plus 1. So timesing it by 2x plus 1 gives me, first off, 200x cubed as expected. And next I get plus 100x squared. I draw a line across and I subtract. Now the first two terms are going to cancel out completely, so I'm just going to be left with minus 18x minus 9. So now minus 18 becomes my lead term. So I need to divide my lead term over here, 2x, by minus 18x, or sorry, the other way around, divide minus 18x by 2x, and that gives me minus 9. I then multiply minus 9 by 2x plus 1, and I get minus 18x minus 9, and because 2x plus 1 is a factor, I should always get 0 remainder. Okay, so now I know that my function can be written as the factor multiplied by what I've achieved by dividing. And hopefully we can spot this is a difference of two squares. And if you're in my class at the school that I teach, I always give a gold note or an award point to anyone who spots a difference of two squares in the lesson. And this is a perfect one here because we have 100x squared, so the square root of that is 10x, and we have 9, which the square root of that is 3. So we write 10x minus 3 times 10x plus 3. And that's equal to 0. So the solutions are x is equal to minus a half. Let me just write here that 10x minus 3 can equal 0. So therefore 10x can equal 3. So x can equal 3 over 10. And again here 10x plus 3 could equal 0. So therefore minus the 3 divided by 10, x is equal to minus 3 over 10. And we have our solutions. Here's a quadratic graph between 0 and 6. It says by drawing a suitable linear graph on the grid, work out an approximation to the solutions x squared minus 7x plus 9. Okay, so I'm just going to write the graph here, which is x squared minus 6x plus 5. Now, what could I do to this equation in order to turn it into this one? Well, at the moment it's got minus 7x, so I could add an x right here, and that would give me minus 6x, and it has a 9 here, so I could subtract a 4, and that would give me 9 subtract 4 gives me 5. And of course, if I have an equation and I do something to one side, I must do it to the other side as well, so add an x and minus a 4. So what will that give me? Well, the x squared won't change. Minus 7x plus x is minus 6x, and 9 minus 4 is plus 5. And on the right side, I get x minus 4. So this is the graph. Right here, like this, already plotted for us. So to solve the equation, I would just need to plot this graph and see where the two intersect. So I'll need to plot the graph of x minus 4, which is going to go through the axis at minus 4, and it's going to have a gradient of 1. So it's going to go up 1 and 1 all the way up. So I'll draw a straight line through there, and then I will look to see what the x coordinates are of these intersections. So I go down here, and that to me looks like 1.7. And I go here, and that to me looks roughly about 5.3. So those are my two approximate solutions. Okay, here is a triangle and it says use the cosine rule to work out the value of x. Okay, so the cosine rule revolves around whatever angle you're going to use. So the angle here is 60, which means that I'm going to call this side capital A, and the side opposite is little a, and the other two sides are B and C. So the cosine rule states that a squared is equal to b squared plus c squared minus 2bc cosine of a. So let's substitute what we know into that formula. A squared is 7 squared, b squared is x squared, c squared is 3 squared, minus 2 times by x times by c is 3, and then multiplied by cosine of 60. Simplifying, this gives me 49 is equal to x squared plus 9 minus 6x multiplied by cosine of 60. Now what is cosine of 60? Well, I've already drawn this triangle once in this video, but I'll draw it again. 2, 2, 1, 1. This will be root 3. This is an equilateral triangle, so this angle here is 60. So the cosine is the adjacent, in this case 1, over the hypotenuse, in this case 2. So the cosine of 60 is a half. So times by 1/2. So simplifying further, it's going to give me x squared plus 9, and this is going to be minus 3x. And setting it equal to 0, because it's a quadratic, is going to give me x squared minus 3x, subtract the 49 gives me minus 40. And I can factorize that, so I write x, and two numbers to times together to get minus 40, and add together to give minus 3 are minus 8 and positive 5. So I write minus 8 and positive 5. This gives me two solutions, x equals 8 and x equals negative 5. But of course we must reject the negative solution because x represents a distance or a length and it cannot be negative. So only one solution, x equals 8. Okay, let's start with this clue that it is less than 0, so it's below the x-axis when x is less than or equal or just less than 5. So every part along here is going to be below the axis. And when x is equal to 5, then y, or greater than 5, then y is greater than equal to 0, which means it's going to be above the axis. So for the blue part there, it's above the axis, which means it's going to have to go through 5 like that. Okay, next clue. It's increasing for x is less than or x is less than minus 1. So in this interval, it's getting bigger. And then here, the next interval, it's going down. And then finally, it's going to be getting bigger again all the way up to here. So it's increasing, which means that the graph is going to be going up like that. And then it's decreasing, which means it's going to be going down like that. And then it's increasing again, which means it's going to be going up again. And that shall do it. What I might do is just make it a little bit curvier, because it is a cubic, so it is a curve, it's not a straight line. So something like that would be acceptable. And in fact, I'm just going to make sure that it goes all the way up to x equals 6 right there, so that it covers all of the domain that we've been asked to cover. Miriam's date of birth is the 14th of September 2006. She makes a 4-digit code with these digits, and it must not start with a 0, and it must have all different digits. So let's first start by listing all of the possible digits in her birth date, and there are 6 of them. And then I'm going to draw 4 slots, and we're going to put how many digits can go in each possible slot. So it must not start with a 0, which means there are 5 options for the first slot. Now the second slot could have a 0, but what it can't have is the digit we used for the first slot. So therefore, out of these 6, we can't use the one which she's already used, so there are now only 5 left over. And the next one, we've used 2 digits already, so therefore there are 4 left over we could choose from. And the final one, we've used 3 digits, and there are only 3 digits left. So I need to multiply these numbers together. Realise I haven't got a calculator, so let's try and do it in the simplest way I can. So 5 times 4 is 20. 5 times 20 is 100. So my final answer is going to be 300. We have a triangle. The perpendicular from A meets BC at D. Okay, and BC we're told is 6 plus 2 root 7, and the area of the triangle is 3 plus 3 root 7. Work out the length of AD. Okay, well we know that the area of course is equal to half multiplied by the base times by the height, and the area in this case is given to us as 13 plus 3 root 7. The base is also given to us, BC, as 6 plus 2 root 7. And the height is actually what we're looking for because the height is AD. Okay, first off I'm going to get rid of this half. I'm going to multiply into this bracket there because that is all divisible by 2. So that's going to be helpful. I don't need the brackets on the left hand side anymore. So this is going to give me 3 plus root 7 multiplied by AD. So AD will be equal to 13 plus 3 root 7 divided by 3 plus root 7. I'm going to have to rationalise that. So I multiply top and bottom by the same as the denominator, but with the sign switched top and bottom, so the actual value does not change at all because essentially we're timesing by 1. Okay, so the top becomes 13 plus 3 root 7 multiplied by 3 minus root 7, and the bottom becomes 3 plus root 7 multiplied by 3 minus root 7, like such. And we expand the brackets, so I get 13 times 3 is 39. I get 13 times minus root 7, which is minus 13 root 7. And then we have 3 root 7 times 3, which is 9 root 7. And then finally we have 3 root 7 times minus root 7. So the 2 root 7s will turn into a 7, times by 3 is 21, and there's a minus sign there. And that is all over. 3 by 3 is 9. Root 7 times 3 is plus 3 root 7, and then 3 times minus root 7 is minus 3 root 7. They will cancel as they always will do. And again, root 7 times root 7 is 7, but there's a minus sign there. Okay, nearly done. 39 minus 21 is 18. How many root 7s do we have on top? Minus 13 plus 9 is minus 4. And that's all over. These two cancel out. 9 minus 7 is 2. Divide both terms by 2 gives me 9 minus 2 root 7. Perfectly fits there on the answer line. Love that. Okay, classic question this. We're looking at powers of 2. So I need to write each of my indices as a 2. So 8 is 2 to the 3. And this one is already 2 to the 56. And 4 is 2 to the 2 to the power of 26. And that's all over 30, which I can't write as a power of 2. When I have a power of a power like that, I can multiply the two powers together. So I get 2 to the 3x. And here I have 2 to the 56 minus 2. I can multiply those two together, and that's going to give me 52. And that's all over 30. Now here comes the tricky step, and that's spotting that these two terms share common factors. They actually share a lot of common factors because they're made up of just 2 multiplied by itself, in this case 56 times and 52 times. So what I can write then is that they both share a 2 to the power of 52. Now what do I need to multiply 2 to the power of 52 by to get 2 to the power of 56? By 2 to the power of 4, because when I multiply them I add the powers and that gives me 56. And here I just need to multiply it by 1 in order to get 2 to the 52. And that's all over 30. Okay, I'm going to move up here. And 2 to the 4 is 16, minus 1 makes 15. So I've actually got 2 to the 52 times 15 over 30, which is going to simplify to 2 to the 52. 15 over 30 is a half, so this is divided by 2, which is 2 to the 1, and when I divide 2's, I subtract the powers, so I get 2 to the 3x is equal to 2 to the 51, so therefore 3x is equal to 51, because the powers must be equal if the bases are the same. So x is equal to 17. What a question that was. That was lovely. This one doesn't look as lovely. Question 23. We have got a lot going on here. We have got these points around the circle. We've got a tangent. We have chords. We've got parallel lines. And it says that angle FHJ is equal to 2x. Okay. Give reasons why FKJ, where is that? FKJ. So that's this angle up here. And angle HJK. So H to J to K. So this angle in here are also equal to 2x. Okay, well I can do that fairly straightforward because this here is a z, because these two lines are parallel, which means that this blue angle is the same as 2x, and that rule is called alternate angles. So the blue one is alternate angles are equal, and the yellow one, it comes from the circle theorem that angles in the same segment are equal. If I draw, so this is the other segment, so we can say that angles from the same segment are equal. Okay, it says work out the values of x and y. You must show your working. Okay, so from the previous question, we worked out that fkj, which was this one up here, is 2x. And we also worked out that hjk, which is this one in here, is also 2x. So by looking at this triangle here, we've got all three angles labelled. So I can write that 2x plus 2x plus 7y must equal 180. So 4x plus 7y equals 180. So I'm going to have to find out more information because that cannot be solved without another equation. So I'm going to look at this 3y because we haven't used that yet. And I know by alternate segment theorem that that's equal to this angle in here. If you have a tangent which meets a side of a triangle inside of the circle, then the opposite angle over here will be the same as that angle between the side and the tangent. So this in here is 3y, and that's great because now I've got this triangle where I know all of the angles. So I can write that 2x plus 3y plus 98 equals 180, which means that 2x plus 3y is equal to 82. So I'm going to need to solve these two simultaneous equations. So let's multiply the bottom one by 2. I'll keep the top one the same, and that's going to line up the x's. And we'll double to get 4x plus 6y is equal to 164. We will subtract to get 1y is equal to 16. We will then substitute back into this equation here to get that 2x plus 3 times 16 is equal to 82. And we know that 3 times 16 is equal to 48. So therefore 2x is equal to 34, which means x is equal to 17, and we are done. Fantastic. I hope you enjoyed that. I hope you found that useful, and if you did, please could you like this video? That would be much appreciated. And if you've not done already, subscribe to the channel because I'm going to be producing lots more content over this exam period on GCSE maths and also this AQA level 2 further maths. Let me know how you found the paper in the comments and stay tuned for more content. See you later. Bye.